All right, so today we will be talking about energy forms and the essential question. How do we identify energy transformations that are taking place around us every day? So, how do we identify them? So, first of all, let's tackle what energy is. So, energy is the stuff, right, that makes things or stuff do stuff, a lot of stuff. Or it's the ability to do work. So, remember when we talked about inclined planes, work is force times distance. So we talked about how work doesn't change with an inclined plane, but the amount of force does because you increase distance. So now when we're talking about energy, we're talking about the energy is the ability to allow work to happen or to take place. So the law of conservation of energy. So make sure this is written down in your notes. This is that states that energy cannot be created or destroyed, but is transformed, not created. Energy just doesn't come out of nowhere. It's transformed from one form to another. So an example, when you light a match, chemical energy transforms, all right, into radiant energy, which is light. So you see the light when you strike it. Okay. And then thermal energy finally in the form of the heat that comes from the match. So it goes from chemical to radiant to thermal. So there's a couple transformations that take place there. Now, the two types or kinds of energy we have talked about before, we have PE, which is potential, and KE, which is kinetic. So just a quick recap on those. Potential is energy that is stored, and it's due to the height of an object. So examples, books on a desk, top of a mountain, top of a slide, water on top of a waterfall, and that we've talked about. This should just be a nice little recap for us. And then kinetic energy is the energy from motion. So the faster an object is, the higher its kinetic energy. So books falling, a roller coaster, right? Going at the bottom of the hill when it's going really fast, sliding down a slide, etc. Recap time number one. All right, so explain the law of conservation of energy. So on your note paper that you have, on the back side, there's plenty of space. You're going to write the recap time. So explain what the law of conservation of energy is in your own words. And then can you also explain the difference between kinetic and potential energy in your own words? Those should be very simple questions done on the back of your paper. All right, so now we're going to look at the actual different forms of energy. So we're going to look at how one form transforms into another. So we need to know what the forms are so we can know what the transformations look like. So we have mechanical, heat or thermal, chemical, electrical, electromagnetic, which is also radiant or light, and then nuclear. So mechanical energy, this is energy of motion or position. It's sound, wind, waterfall, compressed spring, moving machine parts. So mechanical is energy of motion. All right, so there's motion involved, mechanical. Electrical energy is the moving of electrical charges. So electricity from batteries, power lines, lightning, those are all examples of electrical energy. So think about electricity, right? Pretty simple. And make sure that that is written down on your paper. So electromagnetic or radiant light energy is energy that travels in waves. It has electrical and magnetic properties. So it's energy that travels in waves. So light travels in waves. Magnetism, X-rays, radio waves, microwaves, ultraviolet or UV, and infrared radiation. All of those things travel in waves. So they're going to be electromagnetic or radiant energy. Okay. Heat or thermal energy. So there's the internal motion of an object's atoms and molecules. So it's measured by temperature. So heat, obviously measured by temperature. The faster the particle moves, the more thermal energy they have. So an example there obviously is fire. So if they're moving really quickly, they have more thermal energy. Okay, the faster they move, the more thermal energy is created. And then nuclear energy. This is energy stored in the nucleus of an atom. Nucleus kind of makes sense. This is the most powerful form of energy. This is potential energy only. Okay, potential energy only. Fission, which is the breaking apart of, and fusion, which is the forming. So the sun is a form of nuclear energy. And then finally, chemical energy. This is energy stored by chemical bonds in an object. So it's stored by chemical bonds in an object. When the bonds are broken, energy is released. So if you have those bonds together, and they're holding something together, they're storing it. And then once they break apart, that chemical energy is released. So things like gasoline, food that you eat, coal, and wood are all examples of chemical energy. Recap time number 2. All right, so describe the following types of energy. So you have light or radiant, mechanical, chemical, thermal, electrical, and nuclear. So just in your own words, just a quick little description of each one to help you remember what they are. Recap time number 3. So what you're going to do is you're going to write these down: windmill, flashlight, microwave, firecracker, bicycle, and battery. And what you're going to do is you're going to try to guess or use your notes. So it's an educated guess, more like a hypothesis, how the energy is transforming through these objects. So the windmill, maybe you think it starts with mechanical energy, so you write mechanical. And then what does it transform into? Flashlight, same thing. Microwave, firecracker, bicycle, and battery. So what type of energy does it start off as, and what does it transform into as it's being used? So go ahead and pause the video now, write that down on your paper, and then continue the video. Pause. Welcome back after the pause. Here are the answers for the previous slides recap time. So for the windmill, it's mechanical or wind, and then it turns into mechanical, which is turning the blades. Flashlight is chemical and electric, which is the batteries, and that transforms into radiant, which is the light, and thermal. You have the microwave, which is electric and transforms into radiant, the mechanical, which is the sound, and thermal, which is heat, which makes your food nice and warm and delicious. Firecracker, you have chemical, which transforms into thermal, which is from heat, radiant, which is light, and mechanical, which is the sound. A bicycle, chemical cells in your body because you have to have energy to ride the bicycle, turns into mechanical, which is your legs pedaling, and mechanical because the bike is moving. So you see how mechanical, pedaling, and bicycle moving, those are mechanical because there's movement involved. And then finally, the battery is chemical and electrical, and it says nothing until it is used, because remember, it would be potential energy. Batteries are a form of potential energy until it's actually used. So if it was used in the flashlight, then it would transform into the next type of energy. Recap time. All right, so can you give an example of electrical to thermal, an example of chemical to thermal, remember thermal's heat, and an example of electrical to mechanical? Pause the video now and then answer those on your paper, and pause. Welcome back. All right, so the answer to the previous recap time, we have electrical to thermal. Here's just some examples. Electric blanket, hair dryer, electric heater, electric stove, toaster. Pretty much anything you plug in that creates heat is a great answer. All right, so chemical to thermal, here's some examples. Chemical digestion, when you digest food. Burning of fossil fuels, and a lighter, right? Get a lighter going. And then electrical to mechanical, you have a blender, make a delicious smoothie, a mixer, a baby swing. I have little kids at home, they like getting a little swing. And then a ceiling fan. Those are all just examples of electrical, right? Electrical energy transforming to mechanical because it causes movement, right? A blender moves, a mixer moves, a baby swing moves, they all move. So it's something that's electrical energy that then goes into movement or mechanical energy. Thank you so much for learning about energy transformations.